So for estimating the capital cost of a plant, right, we start with potential information about the cost of equipment. We may have information about older equipments, right, data of older equipments at different scale. So you may use the 6/10 rule or any other equation like I mentioned before, right, if you know the exponent, to compare the cost and the capacity of the equipment. You can also extrapolate using time, consider the effect of time in prices. You can use this CEPC value or the cost index value, not only for equipment cost, but also for plant cost. If you estimate a plan in another year and then this year, but you have to make sure that all of the numbers are in the same time scale. So if you don't have a lot of data, right, you can use different techniques to actually calculate the cost of a chemical plant. You have two main techniques, right, the land factor technique and the module costing techniques. We're going to go through all of them. So just for you to have an idea of the order of magnitudes of these estimates, right? So you have like the ones that I show you, right? The method of Hill. Basically, you have the different cost indexes like the Marshall-Swift or the CEPC, and basically you can also use the 6/10 rule for production. You can also, and in there, just to make sure, when you have those type of methods to estimate, you are in the order of magnitude estimate. So the precision of that method is not the best. So you can also do study estimate, and those estimate include what we call the method of Lang, or the land factor method. So basically what you have is different factors attributed to the different type of plants. I'm going to show you that in a moment. And then you also have, notice there that the accuracy is a little bit better, right, than order of magnitude. Here you have plus or minus 35% of accuracy. And then you have the preliminary estimate type of studies, which is the studies that we do in this class and process design courses. And here we use the method of Guthrie. Here we're going to be using the bare module cost, and from the bare module cost that is based on the purchasing cost that I explained before in the previous lecture, then we're going to be getting factors associated to the different materials of construction, pressure factors. We're going to have equipment type of factors. We can use these numbers and actually compare see the effect of time, right? So if you calculate the bare module cost at one particular moment of time, you can use the CEPC value and then convert that to another year. And then you also have quote or estimate. So basically that's for every equipment that you have in the plan, you can ask for a quote, and that will give you exactly how much it's going to cost you. So in these classes, again, we're going to be using the preliminary estimate approach. So this is the land factor technique. It's pretty useful if you need to have like a preliminary estimate. So basically the total module cost, remember the total module cost is the cost for installing the actual unit operations that you design in the plant. This is not considering the grassroots, right? Do not consider any type of unit outside the battery limit. If you don't understand what I'm saying, I already published some videos talking about the boundaries of a chemical plant. So the total module cost, right, for a plant is basically adding all the cost of equipment, the purchasing cost of equipment, and multiplying that for a factor that is called the land factor. So notice in the bottom table that the land factor depends on the type of chemical plant. So you have fluid processing plant, solid fluid processing plant, and solid processing plant. The limitation with this is that not all of the plants have one unique type of fluid, and the other, so you may have things in between, right? And the other thing is that this equation do not considers pressure and materials of construction, right? So changes in that. We are assuming that in the factor, the fluid processing plants, they tend to have like more corrosion, higher temperature. So the factor is kind of higher than the other ones. However, there's no resolution about the process condition and of the equipment that we know impact the cost of purchasing, right, for that particular equipment. Once again, greater land factors, less purchase cost contributed to the plant cost, so solid processing plants are more favored. The limitations are typically intensive to change in process configuration, especially for categories in between table 7.7. So anything that is in between, this is just what I mentioned, it may be hard to calculate, and it doesn't, again, consider materials of construction and high pressure. So module cost techniques are the techniques that we're going to use in this class. They're best for making preliminary cost estimate, relates all costs back to the purchase cost of an equipment evaluated for some base condition. Deviations from base conditions are handled using multiplying factors that depend on the specific type of equipment. So if we're using, as I mentioned before, we calculated this, the bare module cost. If we're dealing with equipments that are vessels or are heat exchangers, compressors, depending on the type of equipment, you're going to see that we're going to have a specific formulas for them. You also have the penalties or cost penalty related to the system operating at pressures that are not 1 atm. And also the effects of changing the materials of construction. That is a relationship mostly, right, on the pressure of the vessel and particularly the temperature, right, and the type of fluid and the comparability of the fluid with the materials of construction for that particular equipment. To calculate the cost of a plant, right, we need to estimate the purchase cost or the base cost at base conditions, right? Once again, base condition means 1 atmosphere and room temperature. We also need to consider this install cost, and often they're 3 to 8 times larger than the purchase cost because installation of the equipment requires a lot of things like materials, personnel. You're going to see a list and a list of what that entails. Remember that equipment free of board, right, it means free on board. That is a term in international commercial law specifying at what point respective obligation, cost, and risk of involvement in the delivery of goods shifts from the seller to the buyer and under the Incoterms standard published by the International Chamber of Commerce. So this is like the legal term, what it means, but basically it's the equipment as you purchase it from the company, right? So and then you purchase that equipment, but you are the person entitled to pay more to see the installation for the particular use. There are a couple of factors affecting the costs associated with the evaluation of capital costs in the plan. So I'm going to just summarize them. So the direct project expenses, they include, of course, the CP, which is the base equipment cost. Remember that all of the costs that we are going to be calculating right now, they depend on the purchasing cost. So here's the purchase cost of equipment at manufacturer's side. Then we have the materials for installation. That includes all piping, insulation, fireproofing, foundation and structural supports, instrumentation and electrical and painting associated with the equipment. The labor for installation, that includes all labor associated with installing the equipment and materials mentioned in A and B, which is going to be the 2 previous paragraphs that I just read, or terms. The indirect project expenses, right, includes freight, insurance, and taxes that basically are all transportation costs for shipping equipment and materials to the plant site, all insurance on the items shipped, and any purchase taxes that may be applicable for that. Construction overhead that includes all fringe benefits such as vacations, sick leave, retirement benefits, labor burden such as social security, unemployment insurance, and salaries and overhead for supervisory personnel. Contractor engineering expenses include salaries and overhead for engineering, drafting, and project management personnel on the project. Indirect project expenses, these are things that companies try to mitigate. For example, they tend to have they may subcontract, right, these services in order for them not to pay that in their own plant, right, in the implementation. So some services are contracted, but again, you have to anyways pay. And when you're doing a preliminary analysis, you need to include them, even if your company decide later or not to just subcontract this personnel or use their own personnel to do the installation. Contingency and fees, right, is the other factor. Here you have contingency is a factor to cover unforeseen circumstances. This may include loss of time due to storm and strikes like hurricanes, right? Small changes in design and unpredicted price increases, particularly if you have a product that may be volatile, right? Or a technology that may be changed, or maybe a utility that is depending on fossil fuels, and that changes with the economics and the price of crude oil. You also have the contractor fee. This fee varies depending on the type of plant and the variety of other factors. Auxiliary facilities is another thing affecting the plan. Remember that I explained before the battery limits, right? So all the way to contingency fees, it is included in what we call the total module cost. So when we calculate the grassroots cost, now we are including facilities that serve the plant that is designed in the battery limit. So if you have if you're designing a chemical plant that is going to be part of a complex that is already in place, probably the fourth factor may not be included in your calculation if you already have the site development, the auxiliary buildings, and the off-site utilities. Okay, so in terms of site development, you have purchase of land, grading and excavation of the site, installation and hookup of electrical, water, and sewer system, and construction of all internal roads and walkways and parking lots. When you're designing a chemical plant, you need to ask these questions to the people that are asking you to do the design. You need to know what is available, what do you own, are you going to have some raw material available so you can save some money, and all of that will be translated into the economics, right, of the design. Also, ancillary buildings include admin offices, maintenance shop, control rooms, warehouse, service buildings like cafeteria, dressing rooms, medical facility. Off-site and utilities includes raw material and final product storage, raw materials and final product loading and unloading facilities. An example is coal. If you're using coal, like in a plant generator, energy generator plant, you need coal to heat up the steam, right? The water to become steam, and the steam move the turbine. So in that case, you need to have the railroads created so you can have transportation of your raw material. You can include also all the equipment necessary to supply required process utilities, cooling water, steam generation, fuel distribution system, central environmental control facilities, and fire protection systems. So now in the next video, we're going to go through the different calculations of costs in a chemical plant.